All right, so let me show you another way of understanding the idea of finding an inverse, the inverse of a sine. So let's say we have sine inverse of, let's do an easy one, sine inverse, well, they're all easy, honestly. Sine inverse of square root of 3 over 2, right? Equals. And that this is saying, what this is asking you is what theta angle on the interval from negative pi over 2 up to pi over 2 will give you the y coordinate of square root of 3 over 2, right? And of course we can just look at the unit circle and we can see, oh, there it is. You know, this is our range for sine inverse. Therefore, it's got to be one of the angles from here up to here. There's square root of 3 over 2. The answer is pi over 3, right? Okay, it's an easy answer. Well, it's not as easy for doing tangent, cotangent, secant, and cosecant. And because it's not as easy for doing those 4 trig functions, I want to show you sort of an expanded technique for doing these sine inverse and cosine inverses, right? We know that this is asking the question, what theta angle? So over here on the other side of the equal sign, we can turn this into an equation and say is equal to theta. So sine inverse of square root of 3 over 2 is equal to theta. Now we have an equation that has a variable, theta. Now we can solve for theta. The question is, how do we cancel sine inverse? Well, I indicated how you could cancel something in the last video. In the last video, I said that if you apply the inverse of a term or an expression, then it will cancel it out, right? So here's what I'm saying. This is a little weird, but I want you to understand this. The inverse of sine inverse is sine, right? Inverse of sine is sine inverse. Therefore, the inverse of sine inverse is sine. And so let me show you what I'm going to do here. I'm going to use a different color, okay? What I'm going to do is I am going to sine each side of the equation. I'm going to do sine of sine inverse of square root of 3 over 2. Now, if I do that to the left side of the equation, if I do sine of the left side, I also have to do sine of the right side of the equation, right? Because it's algebra. Whatever you do to one side, you have to do to the other side. Now, over on the other side of the equation, that's very easy. It just gives us sine of theta, right? So over on this side, very simple, is sine of theta. Well, what's going to happen over here? Well, when we do sine of sine inverse, remember what inverses do to each other is they cancel each other out. And so sine of sine inverse is going to cancel out sine inverse, and the only thing, and it's also going to cancel out the sine, and the only thing that's going to be left is square root of 3 over 2. Square root of 3 over 2. And now we have a much simpler equation, and I'm going to flip it around so it looks a little easier. Now we have sine of theta is equal to square root of 3 over 2. And now all we have to do is look at the unit circle and find where sine of theta is equal to square root of 3 over 2. You know what theta angle, and that is pi over 3, right? That would give us square root of 3 over 2. Remember, it still has to be between negative pi over 2 and pi over 2. Okay, so the answer now is theta is equal to, is equal to pi over 3, and that is our answer. Okay, now that is too long of a process to answer sine inverse and cosine inverse problems, because sine inverse and cosine inverse problems, you can just see the answer right there on the unit circle. So you don't have to go through all those steps to be able to get the answer. But when you want to solve for tangent inverse or cosecant inverse or something like that, then you have to, it makes a lot more sense to use an algebraic procedure to come up with an answer. So what we're now going to do is we're going to move on to trying to understand the inverses of tangent, cotangent, secant, and cosecant. All right, so before we jump into being able to figure out the inverses of these other trigonometric functions, I want to go over a couple of preliminaries, okay? The first preliminary is I just want to briefly review the formulas or the relationships of tangent, cotangent, secant, and cosecant to sine and cosine, because ultimately we're going to need sine and cosine off the unit circle to be able to identify our other four trig functions. So remember that tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. Sine over cosine. Cotangent is the reciprocal of that, cosine over sine. Secant of an angle is the reciprocal of cosine, so 1 over cosine. And cosecant is the reciprocal of sine, or 1 over sine. Okay? All right, so I just wanted to review that. So the second preliminary I want to go over is you may be asking the question, do the inverse functions of these four have restrictions on their range the same way that sine and cosine inverse have restrictions on their range? And the answer is yes. Okay, and let me go ahead and indicate those to you now, because it's a little confusing. Now, secant and cosecant are very simple. Secant, because it's 1 over cosine, secant has the exact same range restriction as cosine. So secant inverse, I'll put it down here, secant inverse, okay, has a restriction of 0 up to pi. Similarly, cosecant inverse has the same restrictions as sine, which is negative pi over 2 up to pi over 2. Okay? And so now that just leaves tangent and cotangent. And so very simply, what has been decided for tangent is that the restriction for tangent inverse is the restrictions for sine. Okay? Basically, it's what's in the numerator, but that's just one way of remembering it. So for tan inverse, the restriction is going to be from negative pi over 2 up to pi over 2. And then the restriction for cotangent inverse is going to be the same restriction for cosine, which is from 0 up to pi. Okay? All right, so now that we understand that, we know that all of our answers for tan inverse have to fall between negative pi over 2 and pi over 2. Same for cosecant inverse. And then all of our answers for cotangent inverse and secant inverse have to fall between 0 and pi. Okay? All right, so now that we understand that, we have those preliminaries, now we can actually look at how to solve one of these answers. All right, well, let's say that I wanted to know what is tan inverse of the square root of 3. Okay? Tan inverse of the square root of 3. So the problem here is we can see some square root of 3's on the unit circle, and for very clever people who are very intuitive or have a good understanding, they might actually be able to figure this one out without algebra. But I need to show you a foolproof procedure for being able to answer this. Okay? And so what I'm going to do here is this: we're going to start off with tan inverse of square root of 3 is equal to theta, right? And now what we're going to do is we're going to use that procedure where we cancel tan inverse. Okay? So I'm going to do tangent of this whole side of the equation, and I'm also going to do tangent of this side of the equation. So over on that side of the equation, I now have tangent of theta. And over on this side of the equation, the tangent and the tangent inverse are going to cancel each other out, and we're going to have the square root of 3 left over. And so what we have now is tangent of theta is equal to the square root of 3. Okay? Now, what I'm going to do is I'm now going to transform tangent. What I need to do is, this is not going to help me. I need this to be in terms of sine or cosine, or both sine and cosine. Okay? And so I'm going to turn tangent into sine of theta over cosine of theta, okay? And I'm going to bring down the square root of 3, okay? And so now, because this is a fraction over here, we got sine over cosine, we want to make this one a fraction over here. We want to do square root of 3 over 1, okay? And now, here's the other thing. You know, we kind of understand that on the unit circle, most of the coordinates are all over 2, right? Over 2, over 2, over 2, over 2. The only ones that aren't are these whole number ones here, okay? But this is not a whole number, okay? So therefore, here's what we're going to do. We're going to do something sort of tricky here. I mean, it's not that tricky, but if we multiply by 1 half over 1 half. So if we now multiply by 1 half over 1 half. Now, multiplying by 1 half over 1 half, this is something we do not have to do on both sides of the equation. You may be asking, yeah, but the rule of algebra is whatever you do to one side, you have to do to the other side. Except for there's another rule of algebra, and I don't know how familiar you are with this rule, is that you can always multiply by 1. You can multiply any term by 1, you can multiply any expression by 1, you can multiply any side by 1. You can multiply just the denominator by 1. You can multiply any component of an algebraic equation by 1 and it doesn't change the equation, because when you multiply by 1, you're not changing the value, okay? But what we do oftentimes in algebra is we convert the 1 into something else, just like rationalizing the denominator. You know, when we have 5 over the square root of 7, if we want to rationalize the denominator, we multiply by the square root of 7 over the square root of 7. Well, square root of 7 over the square root of 7 is equal to 1, because we have the same thing in the top and the bottom. Therefore, this will not change the value. So, multiplying by 1 half over 1 half is the same thing as multiplying by 1. And 1 half times the square root of 3 is the square root of 3 over 2. Over 1 half times 1, well, that's 1 half. And if this is equal to sine of theta over cosine of theta, well, then now we can find our answer for theta by just finding the coordinate where cosine is 1 half and sine is square root of 3 over 2. And it has to be on the interval from negative pi over 2 up to pi over 2, because we're dealing in tangent inverse. So between negative pi over 2 and pi over 2, the coordinate that has cosine 1 half and sine square root of 3 over 2 is pi over 3. And therefore the answer to theta for this question is pi over 3. Okay? All right, let's try one for cotangent. All right, so let's try and identify cotangent inverse of negative 1, okay? All right, so again, we're going to put in a theta here, okay? Then to cancel the cotangent inverse, we are going to do cotangent of both sides. So cotangent of the left, cotangent of the right. Over on the right side, we're going to have cotangent of theta, okay? Good. Cotangent of cotangent inverse, that's going to cancel, and all we're going to have left is negative 1. All right? And so now we're going to convert cotangent into sine and cosine. Well, cotangent is the same thing as cosine of theta over sine of theta is equal to negative 1. Okay? All right, so I know that what I showed you in the last example would mean that we would now put this over 1, right? Because we have a fraction over here, and we're going to do this over 1. Well, nope, we're not going to do that. See, this is one of the things that makes these things weird. What we have here is negative 1. And the problem with negative 1 is this is, well, ignore the negative for a second. The problem with 1 is, remember what we just said about 1 being equal to a fraction where you have the same thing on the top and the same thing on the bottom? So whenever you have a function is equal to just 1, something you have to think about is this. First of all, it's negative, okay? And what we need here is we need same over same. We need something, a value, where cosine of theta is the same thing as sine of theta, because you can only come up with 1 if your fraction has the same thing on the top and the bottom. Well, we know that there's only one kind of coordinate on the unit circle that has the same thing for cosine and the same thing for sine, right? And that is all of our over 4s, right? So here's an over 4 and here's an over 4, right? Now, because this is cotangent, we're working on 0 through pi. So between here and here, we know that our answer must be either pi over 4 or 3 pi over 4. But let's not get ahead of ourselves too much. So we know that the same over same is going to be square root of 2 over 2. So we know that same is square root of 2 over 2 over square root of 2 over 2. That's the only way you're going to have same in trigonometry, okay? Is you're going to have same over same, but it's negative, right? And that's going to be equal to cosine over sine. And so here's what this negative means. This negative either has to go on the numerator or it has to go on the denominator. So we're either dealing with cosine of negative square root of 2 over 2 and sine of positive square root of 2 over 2, or cosine of positive square root of 2 over 2 and sine of negative square root of 2 over 2. Well, the one I just said, where cosine is positive and sine is negative, that is not on the interval from 0 to pi. The only one that's on the interval from 0 to pi is where the x is negative and the y is positive, or cosine is negative and sine is positive. Therefore, this negative has to go on the numerator. So, what is the theta angle where cosine is negative square root of 2 over 2 and sine is square root of 2 over 2? It's right over here. It is 3 pi over 4, and therefore the answer for theta here is going to be 3 pi over 4. Okay? All right, I think now we should try a secant and then a cosecant. All right, so let's say we have secant inverse of negative 2. Okay? Now, because it's secant, we know it's related to cosine. Therefore, it's going to have the answer to this, the theta angle, is going to be on the interval from 0 to pi. So we're going to come over here and we're going to put in pi. Not pi, so we're going to put in theta angle. And we know to cancel secant inverse, we're going to have to do secant of both sides, right? I'm using parentheses this time instead of brackets, that's okay. So we'll do secant of this side. Now on the right side, it's going to give us secant of theta. Okay? And on the left side, it's going to cancel secant inverse. And all we're going to have left is negative 2, right? So now we know that secant of theta is equal to negative 2. All right, so now what we're going to do is we're going to replace secant with 1 over cosine of theta. And over here, we're going to bring down the negative 2. All right, now we're going to do a little bit of algebra, okay? So instead of turning this into a fraction, which we could, it's just that it wouldn't proceed as far as you want to go. So when you're dealing with secant and cosecant, instead what you're going to do is we're going to multiply by cosine on both sides, multiply by cosine of theta. On this side, it's going to cancel. So over here, we're going to have 1. And over here, we're going to have negative 2 cosine of theta. And now, to solve for cosine of theta, we're going to divide by negative 2 on both sides. Cancel on this side, and we have cosine of theta is equal to, the negative can go in front of the whole thing, negative, because we've got a positive divided by a negative. So it's equal to negative 1 over 2. And so, what is the theta angle that would make cosine negative 1/2? That's on the interval from 0 to pi. All right, cosine is now we're just back to just trying to figure out, doing the inverse of cosine of negative 1/2. Well, there's negative 1/2 right there, and it's at the theta angle 2 pi over 3. Therefore, the answer to theta here is 2 pi over 3. Okay? All right, now let's try a cosecant, and then after that, we're going to do one more tangent problem. All right, so we've got cosecant inverse of 2 square root of 3 over 3. Okay? Now, cosecant is related to sine because it's 1 over sine. Cosecant is 1 over sine, so that means it's going to be our answer, our theta angle is going to be between negative pi over 2 and pi over 2. So we're going to put a theta over here. To cancel cosecant inverse, we're going to use cosecant, right? Okay, on both sides, cosecant on both sides. It's going to cancel cosecant inverse. It's going to carry down 2 square root of 3 over 3. is equal to cosecant of theta. Okay. Now we're going to transform cosecant of theta into 1 over sine of theta. So 2 square root of 3 over 3 is equal to 1 over sine of theta. Now we're going to do algebra just like we did before. Okay. So we're going to multiply. Well, we can do this a couple ways. Okay, actually, we can cross multiply here if you want to, because now I want to say something about cross multiplication. I've seen so many people do cross multiplication wrong. I can't even begin to tell you the number. Okay, but it is definitely in the hundreds. And I have only been a math teacher for about 11 years. Okay, but I've seen so many people do cross multiplication incorrectly because they think that when you have 1/5 times 7 over 9, that when you're multiplying, you cross multiply. No, multiplying fractions, you go straight across. The only time you can ever cross multiply, ever, is when you have a fraction is equal to a fraction. That is all. If you have a fraction that's equal to a fraction plus something else, you can't cross multiply. You'd have to turn the other side, find a common denominator, turn it into a single fraction. But when you have a fraction, this is a proportion. Whenever you have a fraction equals a fraction, you can cross multiply. Okay? But let's do it the long way. I'm going to multiply by sine of theta here, multiply by sine of theta over here. It's going to cancel sine of theta, and all I have over here is 1. Over here, sine of theta is going to be multiplied by the numerator only, because this is sine of theta over 1. 1 times 3 is 3. So the 3 is going to stay 3. And in the numerator, we're going to have 2 square root of 3 times sine of theta. Now we're going to multiply by 3 and cancel this denominator. Bam! That's why this is, 3 times 1 is 3. Sine of theta times 2 square root of 3. That's where cross multiplication comes from. But we're doing it the long way. So 2 square root of 3 times sine of theta is equal to 3. And now we're going to divide. Now, I am doing this the long way, but I don't care that I'm doing it the long way. I want you to understand that we're doing good algebra here. 2 square root of 3 on both sides. It's going to cancel here. And now sine of theta is equal to 3 over 2 square root of 3. Now the problem here is we need to rationalize the denominator, right? So we've got to multiply by the square root of 3 over the square root of 3. And so that's going to give us 3 times the square root of 3 is 3 square root of 3. 2 square root of 3 times square root of 3. Well, this square root of 3 times this square root of 3 is going to be 3. But I'm not going to do 2 times 3 is 6. I mean, I can, I guess, but it makes it, well, yeah, let's go ahead and do 6. Well, so square root of 3 times square root of 3 is 3 times 2 is 6. Now look what we have. We have 3 over 6. 3 over 6 is the same thing as 1/2. That can be reduced, and we wind up with 1 over 2. 1 times square root of 3 over 2, which is square root of 3 over 2. Okay? And so what we now have is that sine of theta is equal to square root of 3 over 2. And so now all we have to do is find the theta angle between negative pi over 2 and pi over 2 that has a sine of square root of 3 over 2. Well, sine of square root of 3 over 2 is up here, and that is at pi over 3, and therefore theta is equal to pi. That's an ugly pie. I'll still eat ugly pie. I mean, it's like, I don't care if it's a messed up apple pie or messed up lemon pie. I don't care what it is. I'll still eat it, right? It's all going to the same place. Okay, so pi over 3. And so that is the answer to cosecant inverse of 2 square root of 3 over 3. Now, I want to show you something up here. When we were at this step right here, I'm going to I don't have room over here. Let's do it down here. When we were at the step of 2 square root of 3 over 3 is equal to 1 over sine of theta, here's something else I want to show you. Now, don't do this. You could hurt yourself by doing this. But as long as you have a fraction is equal to a fraction and nothing else, just like the cross multiplication, there's another technique you can do where you basically just flip over both of the fractions. Okay, so we're going to flip this one over. And then we're going to have 3 over 2 square root of 3 is equal to, we're going to flip this over. We now have sine over 1, which is just sine. And that was an easy solution for sine right? Now we have to rationalize the denominator. We'll still get the same answer. I just wanted to show you that when you have fraction is equal to a fraction, you can flip them both over, and it might make the solution a lot easier. It is a legitimate technique as long as it is simply fraction equals fraction. Okay. All right, let's do one more. I told you I wanted to do one more tangent inverse problem, and then we'll be done with this particular segment. All right, so let's say we've got tan inverse of 0. Okay. All right, well, we know that tangent uses the sine inverses restrictions, okay? And so we know that the answer has to be between negative pi over 2 and pi over 2. So we're going to go ahead and put our theta angle in here. And to cancel the tangent, we're going to do tangent of both sides, tangent of both sides. Over here, it's going to cancel tan inverse, and we're going to just carry down the 0. So 0 is equal to tangent of theta, okay? All right. Well, we know that tangent of theta is the same thing as sine of theta over cosine of theta. Now, we now have a fraction is equal to 0. We're going to stop just for a second, and I need to tell you, very simply, anytime you have a fraction is equal to 0, automatically the numerator is 0. Automatically. That's the end of the story. The numerator is 0. The denominator can't be 0, because when the denominator is 0, you have an undefined expression, okay, or an undefined term. So we know in this particular case that sine of theta is equal to 0, and sine of theta equals 0. So the angle measure where the y-coordinate is equal to 0 is right here. It's 0. Not 2 pi. 2 pi is not between negative pi over 2 and pi over 2. The answer is 0, and therefore the angle, the theta angle, the answer to this is 0, and we're done. So I'm just telling you, anytime you have a fraction is equal to 0, automatically just ignore the denominator and just take the numerator, set it equal to 0, and solve.